2.2 Elementary Functions, Graphs and Transformations. Elementary functions are sometimes known as basic functions. They are sometimes known as parent functions. And I'm likely to use the term parent objectives for this section. The one that's going to be covered in this video, the student will become familiar with the beginning library of elementary or parent functions. Then in future videos, we will do what parent functions are begging for to be transformed. The student will be able to transform functions using vertical and horizontal shifts. Then reflections, stretches, and shrinks. Finally, the student will be able to graph piecewise defined functions. So the first thing that we see in our library of functions is the identity function, also known as the linear parent function. It passes through the origin. It has slope 1. It passes through the points 1, 1, 2, 2, 3, 3, pi, pi. The first and second coordinates are the same for every point on the graph. The domain is a set of real numbers because you can see that this graph extends infinitely in both directions, left and right. The range is a set of all real numbers because the graph extends infinitely up and down. Squaring function. Squaring function squares its inputs, and it's got points on it like the origin, 1, 1, since 1 is the square of 1, 2, 4, since 4 is the square of 2. The domain, anytime you have a quadratic or second degree function, the domain is always a set of all real numbers. The range, however, is not the set of all real numbers, because if you square a real number, you cannot get a negative. So the range is only the set of non-negative real numbers. Right? This graph, it never extends below the x-axis. Everything is at or above the x-axis. Well, that's the range, the set of real numbers at or above 0. Cubing function behaves like the squaring function for positive values of x over on the right, but for negative values of x, it does extend below the x-axis, because the cube of a negative number, if you multiply a negative number by itself and then by itself again, is a negative number. And so we get, for example, points like -1, -1. And way down here we're going to have a point -2, -8, because -8 is the cube of -2. Domain's a set of all reals, the range is a set of all reals. And that's true anytime you have a cubic or third degree function. square rooting function. This returns the square root of its input. So you have a point on there like the point 42, because 2 is the square root of 4. And the graph is almost entirely in the first quadrant. Everything except the origin is in the first quadrant, because you can only have non-negative inputs. Can't take the square root of a negative and get a real number out of it. And it's also true that the output can't be negative, right? When we say square root of, we're talking about the principal square root, which is the positive root. So the domain is closed interval 0 to infinity, and that turns out to be the range as well. Cube rooting function. Now this one returns the cube root of its input. So you have a point on there 1, 1. You have a point on there 8, 2, because the cube root of 8 are 2. This has origin symmetry, so you can go right across the origin and get a point -1, -1, and a point -8, -2 for this cube rooting function. Domain is a set of all reals, because you can take the cube root of any real number. That's allowed for any real number. And the range is a set of real numbers. The outputs cover the entire vertical dimension. The absolute value function has a familiar V-shaped graph. The absolute value, of course, returns a positive number for a positive input and a positive number for a negative input, and 0 for 0. The domain is a set of real numbers, all real numbers, because you can take the absolute value of any real number. They're all allowed. It kind of behaves in some ways like a squaring function. Has the same domain and range and the same lowest point. Range is 0 to infinity, because everything is at or above the x-axis. Here's a poster I made of parent functions, and you might want to save this and to refer to, or something like it. You see the linear parent function, which in this video we have called the identity function. Quadratic function or squaring function. The rational parent function was actually not on this video, not in the previous slides, but that's an important one. The rational parent function, also known as the reciprocal function. And we've got the square rooting function, and some functions, the graphs of which we'll need to know in the future: exponential and logarithmic. 2 exponential graphs, 1 logarithmic graph. There are actually 2 main ones, but only one is on this poster. There's absolute value function. A couple of others, or one other that might have been among the slides here, the constant function. And down here you can see the constant function has a graph which is a horizontal line. It's for f of x equals b, where b is a real number, that horizontal line will be b units above the x-axis. Of course, for b negative, the horizontal line will be below the x-axis.